I'd just like to introduce a little bit the context of what we describe as the greatest engineering challenge of this decade. Before I do, I'd just like to acknowledge also our partners in setting up this evening, the British Wind Energy Association, up there at the top. And I think between us, we hopefully can cover off most of the questions, most of the angles that we want to debate this evening. So very quickly, what is the challenge and why do we think it's so important? I think there are probably three fundamental drivers that lead to that. The first is climate change, the need to build a low-carbon economy, the need to respond with an energy system that is far more sustainable and lower carbon than what we have had in the past. More specifically, we in the UK need to respond to European targets for renewables production by 2020. Our response to that is to have a 15% response, which is a very significant proportion of our electricity demand here in the UK by 2020. We've looked at all kinds of other technologies. The reality is that we are running out of time with a number of the other options that would otherwise be very attractive. So if we really want to meet the 2020 target, we believe that we are going to be heavily dependent on a very significant uptake in offshore wind to achieve that. So the first real driver for all of this, I think, is the need to build a low-carbon economy. The second, and it's not inconsistent with what a low-carbon economy is all about, is the need to increase security of supply and address increasing concerns over security of supply going forward. And there is no doubt that if we increase the portfolio of renewable power here in the UK, it will improve our overall position in terms of security of supply and our dependence on particularly imported oil and gas. And the third, I think, is something that maybe is particularly relevant to this evening's debate as Justin has just framed it, which is that we see offshore wind as an almost unique opportunity for the UK and perhaps more generally for Northern Europe. The reality is that in the UK we have terrific offshore engineering skills, we have a great deal of wind around our shores, and we have a very good shoreline, very suitable for large-scale deployment of offshore wind. Not unique, but certainly if you look at Northern Europe, you would say that we are uniquely advantaged as a region in terms of developing this technology, to the point where it is questionable whether actually this technology would develop at scale unless we get on and do it here in Northern Europe. So if that's the challenge, in terms of drivers, what's the problem? We've done a lot of work looking at offshore wind. We had a publication last year, and I'm going to refer back to just a couple of numbers from that publication. It's available as a download to anybody who will be interested in it. What we highlighted, I think, was that to build 29 gigawatts of offshore wind, and that's just short of the 32 gigawatts that's been talked around in the round 3 process, it will cost something of the order of 75 billion. Now, there is a big issue in that. You take 75 billion, you take 29 gigawatts of wind, and you end up with a return something around the 8%, maybe a little more, maybe a little less, but something around 8%. And that's not, frankly, going to attract the kind of investment required to make this a reality. So the challenge is there technically. We know how to meet much of that challenge, but it's very expensive. So what can we do to reduce the cost? We identified sort of 2 big areas in which we can work to reduce that 75 billion. The first is by essentially making everything around this investment as easy as possible, working hard on grid and planning issues, finding the best locations for offshore wind around the UK coastline and making those locations available to developers who want to put up their investments in those areas, and so on. So it's basically making the infrastructure as easy as you can, making the context of the investment as easy as you can. The net impact of that is a staggering sort of 16 billion out of the 75 billion. And as a 16 billion reduction, whilst I accept it is challenging, it is too big a number simply to walk away from and say, look, business as usual is far easier. 16 billion is an enormous prize, and I think we all have it in our minds that, look, it really is worth making quite a few changes and making some difficult decisions if that's the kind of end outcome that we can achieve. The second big area of cost reduction is literally through technical improvement in a whole number of different ways. And we believe that there is real potential simply by doing things better, by learning from what we have done, by technical improvements very similar to those that we've seen in the development of other industries, to reduce by a further 14 billion the overall 75. Add the 16 and the 14, you get about a 30 billion reduction. Knock that off 75. And interestingly, the returns on the investment required go up from around about 8% by about 10 percentage points, so to about 18. So wherever you start, add about 10. Now, the reality is Nobody has ever achieved the full cost reduction potential in any development of any industry at this kind of scale. But if we can get even just part of that cost reduction, it's clear that we will then move very rapidly into a situation where major investment and major capital flows will come into the sector, and that's what we need to achieve. So there is every opportunity to reduce the cost going forward. If we manage that, what will then be the impact in terms of our original positions? Well, it's quite clear that we will have saved very significant carbon emissions here in the UK. It's quite clear that we will have improved our security of supply against pretty much any metric. And in terms of the economic benefit, we will have created up to 65 billion of net value for the UK over an extended period of time, and it very much depends on how much of that value, by the way, is generated here in the UK and how much of it is essentially exported or imported. And it could lead to up to 70,000 jobs, we believe, in 2020. That extending out potentially to sort of 250,000 jobs by 2050 or so. So it is an enormous challenge. It's an enormous opportunity in our view. It is broadly akin to building the Eurotunnel every year for the next 10 years. That sounds pretty daunting. From a finance point of view, it's very daunting. In terms of electricity capacity generation, it's actually not out of kilter with the highest rates of new capacity generation being laid down in the UK. We've done it before in the UK, so that's something that can be done technically and is feasible. But it's an enormous challenge. The real question is how much of that challenge can we take advantage of and realise as an economic opportunity here in the UK? That's the subject of the debate this evening.